Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2019 Maths Methods Exam 2 multiple choice section for Maths Methods. So yeah, let's get ready to do this video. Okay, question 1. Let f be all reals, blah blah blah, and f of x is this function. The period and range of f are respectively what? Okay, the period is known to be 2 pi over n. And our n value is what's next to the x. So pretty much 2 over 5. So we can say 2 pi, our n value is 2 over 5. Which you can say that's 2 pi times 5 over 2. These cancel out, leaving us with 5 pi. So that's your period. So E and D are wrong. What about your range? An actual quick way to do the range is look at this and your amplitude. So look at the translation in the y-axis and the amplitude. So first thing I would do is put a square bracket, and this first number, your actual translation, put -2 here. Put a minus first, then your amplitude. Do the same thing, -2. Now put a plus, the 3 here. So that is your range. That's a quick way to do your range. So that'll be -5, 1. So -5, 1. B looks like your answer. The set of values of k for which this has 2 real solutions is. You should straight away know to use the discriminant in this question. So the discriminant is b squared minus 4ac. And we want 2 real solutions, so your discriminant must be greater than 0. So what is our b squared here? This is going to be our a. This is going to be our b. This is going to be our c. So your b in this case is 2. So what's 2 squared? It'll be 4. Minus 4. What's your a? 1. What about your c? -k. And this must be greater than 0. Okay. So simplifying this, we get greater than 0. 4 plus 4k is greater than 0. Which would be, say, 4k is greater than -4. And k is greater than -1. Meaning that our actual k, so k is an element from -1 to infinity. Perfect. Looks like B is your answer for that one. Perfect. Question 3. Okay, f of x is given here where a is greater than 0, so it's a hyperbola. The average rate of change of f from x equals 6 to x equals 8 is what? Okay, I'm going to do this on CAS, just a quicker way. So I'm going to open my CAS and define the function. So f of x is a x minus 4. And the average rate of change is f of 8 minus f on 6, and 8 minus 6, which is 2. Enter. This is your average rate of change, -a over 8. So E is your answer. Question 4. Okay, we get this is equal to what? Okay, just do this on CAS. So shift plus, and from 0 to pi over 6, 8 times sine x plus b times cos x is equal to this expression over here. So I'm just going to write it on my iPad. So a 1 minus root 3 on 2 plus b over 2. So it doesn't look like one of these, but I'm going to simplify it to make it look like it. So a minus a root 3 over 2 plus b over 2. 2a minus a root 3 plus b all over 2. And we can take a as a common factor here, so it'll be 2 minus root 3 plus b over 2. Alright. Well, the one that looks pretty much the same is C looks right. Is that right? Yeah. C looks good. Perfect. let f dash of x equal this, such that f of 4 equals 0. The rule of f is, there's an actual trick that you can do this on the cast. So, for example, let's, there's to pretty much do this in such a quick method. So normally what you'll do is blah, blah, blah. You'll integrate it plus c, and then use that initial condition to shove it in the function, and you get, you solve for c, and then you put it back, and that's your overall function. But there's a quicker way you can do. So imagine that, so when you're writing the integral, normally the integral, and we put the function in it. Imagine, this is a quick way, so in your calculator. What is the initial condition? Look at the initial condition. What is our x and y? Well, our x is 4, and our y means that it's equal to 0. That's what this initial condition means. So what I want you guys to do is pretty much this initial condition, put it at the bottom. So x equals 4, put it at the bottom. And at the top, always put x and put the function in it. So 3x squared minus 2x dx plus your y value. But here our y value is 0, so we're going to just say plus 0. Put this in your calculator, and it will give us a quick method. It will sub it in and do the whole calculations for us. So let's do this on a cast. So what is the integral from 4 to x, 3x squared minus 2x dx? Aha, gives you this. So which one looks like that? It looks like C is your answer for that one. Perfect. A rectangular sheet of cardboard has a length of 80 centimeters and a width of 50 centimeters. Squares of side length x centimeters are cut from each of the corners, as shown in the diagram. A rectangular box of open top is then constructed. The volume of the box is at maximum when x equals y. Okay. Well, we know these sides is going to be 80 minus 2x. And this side over here is going to be 50 minus 2x. And this over here is just your x. You should know how to do these. It's pretty much very easy. So we know that these side lengths here are x, x, yeah, x, x. And imagine constructing a box. You will pretty much, when you construct it, this length over here is these over here. And this is the actual, this length over here is this one over here. So that's why we say 80 minus the 2x, these two x's over here. So, let's write a formula now. So your volume in terms of x is x, 80 minus 2x, 50 minus 2x. So the volume of the box is at maximum. So I'm just going to graph this, make it easier. So go on your CAS, and, okay, so x times 80 minus 2x times 50 minus 2x, and we get this over here. So go menu, zoom fit. All right, let me just zoom it out more to see what we see. Okay. All right, so this is our graph. Okay, perfect. So the maximum, this is our maximum. We want to find where it occurs at the maximum. So go on your analyze graph, maximum. It occurs at x equals 10. So A would be your answer for that one. The discrete random variable x has the following distribution. The mean of x is what? Okay, very easy. First, I'll try to calculate the variable a, and that's easy. The addition of all of this should be equal to 1, because this is probability. So 7 plus 3 is 10, so it's 16. All of them 16a equals 1. So a is equal to 1 over 16. And remember, how to find the mean is you multiply these by these. So at plus these, multiply this by this, plus multiply this by this, blah, blah, blah. So in terms of this, it's going to be 3a plus 10a, 7, 14, 21, so 21a. That is at pretty much completing this, 31 plus 3, 34a. So 34a, this is your mean. But we know our a value is 1 over 16. And say we kind of half it, so it was 17 over 8. Looks like D is your answer for that one. An archer can successfully hit a target with a probability of 0.8. The archer attempts to hit the target 80 times. The outcome of each attempt is independent on any other attempt. If you just see the word independent, it means binomial distribution right over here. Given that the archer successfully hits the target, I just see the word given. I know it's probably conditional probability. The probability that the archer successfully hits the target exactly 74 times is what? Okay, so we're trying to find the probability. So the probability that the archer successfully hits the target 74 times. So let's say x equals 74, given that the archer successfully hits the target at least 70 times. Okay, so first let's try to find, this can be simplified to the probability of x equals 74 intersection x is greater or equal to 70 all over the probability of x is greater or equal to 70. I can simplify this one right over here by just drawing a graph. So imagine this here is 70 and this point is 74, and we know that x is greater than 70. And when do they intersect? And there's also a point here. They only intersect at x equals 74, right on this point. In other words is, imagine these. So at x equals 74 and x equals 70 is greater than 70. When do they intersect? There's only one point of intersection, just right over here, which is x equals 74. So we can rewrite this whole expression as the probability of x equals 74 all over the probability of x is greater or equal to 70. Very nice. So I'm going to use my calculator for this. Okay, so go on menu, probability, distributions. We're going to go on binomial PDF for the first one. So our number of trials is, he does it 80 times. The probability of success is 0.9. And we also know we want to find 74 there. And we get this number. Perfect. The next one we want to do is probability distribution. And we want to go to binomial CDF. The number of trials is still 80. Probability of success is 0.9. And your lower bound here is 70. Your upper bound is 80. And we get this. So what's this divided by this? We get 0.149. Which one does that look like? C is your answer for that one. Nice. All right. The point AB is transformed by this matrix. For the image of A and B is this. So if the transformed of A and B is 0.0, then A and B was this. Okay. So wait, if the image of A and B, so if the transform of A and B is this, okay. So let's just simplify this, like expand this. So it'll be this matrix. So it'll be x dash equals half x minus half y dash is equal to negative 2y minus 2. And what we know is our x dash here is the transformed. And we know the transformed of A and B is pretty much 0.0. So this, our x naught is this, and your y dash is equal to 0. So subbing that in, we can say that's 0, half. Your x in this case is A, minus half. The other one's going to be 0, negative 2, and your y is B, minus 2. Solving for A and B, so A will equal 1, and B will equal negative 1. So your actual intervals is just from 1 to negative 1. Alright, 1 to negative 1. Looks like easier answer for that one. Is that right? Have I done any mistake? Okay, looks good. Which of the following statement is true for this function? The graph of f has a horizontal asymptote. Okay, I would first just draw this graph. Let's just have a look at this graph. So x plus sine x. Okay, perfect. We got this graph that's just repeating like this. Okay, the graph has a horizontal asymptote. Nope, does not look like it. Just goes forever like this and also downwards like that. So nope. There are infinitely many solutions for x equals 4. No, x equals 4 just touches once and it doesn't actually have infinite solutions. The f has a period of 2 pi. Not too sure. So I'll put a question mark on this one. F dash of x is greater or equal to 0 for x's and all element of all reals. So let's double check that. So if I was going to draw a graph, So the derivative of f2 of x. Okay. It is greater or equal to 0. We can see that it touches 0, so it's equal or greater than, and it's greater or equal to 0. So that's true. For all real values, yes. Okay, that is the most suitable. That looks pretty much right. And so I'm going to put D as an answer. F dash of x equals the next one. F dash of x equals cos x? Absolutely not. If you simplify this, it's the derivative is just 1 plus cos x, so which is wrong. So, but f has a period of 2 pi, not too sure about that, but D is an absolute answer. We've just shown it through our graph, yeah. So choose D as your answer. Perfect. A and B are events from a sample space such that the probability of A equals P, where P must be greater than 0, and probability of B given A is M, probability of B A complement equals N. A and B are independent events when. Okay. Alright. So, when I just see independent events, this is what comes up. I know it's going to be the probability of A times the probability of B must equal to your probability of A intersection B. This is how we show this proof for these that it's independent. It has to meet this condition. Let's look at what they've given us here. Well, they've given us this, and if we simplify this, so we're saying the probability of A intersection B all over the probability of A is actually equal to M. Okay, so that's good. And we know the probability of A is what? P. So it's the probability of A intersection B is equal to MP. That's good to have. We'll put it right over here. What about the next thing they've given us here? So the probability of A complement intersection B all over the probability of A complement A equals N. This one right over here can just be 1 minus the probability of A, which is 1 minus P. And so that we know that the probability of A now B equals N 1 minus P. Okay. Alright. So, what can we do here? Well, we need to find the probability of B. Because look, we have the probability of A. We have the probability of A intersection B, which is this. But we don't know the probability of B. So what I'm going to do is I'm going to sketch a nice Venn diagram. Venn diagram. To really represent this. So imagine these. Oops. Alright, something like that. Not the best, but A and B. Okay. We know that this over here is what? It's A. It gives us this. Right over here. So to get the probability of B, we just need to add this over here to the intersection. So we can actually get probability of B. So we can say the probability of B is N 1 minus P plus the intersection, which is MP. Perfect. So that's probability of B. Now, putting this all in this expression, we should find some expression that should help us with this. So, probability of A is MP times N 1 minus P plus MP. Okay. Equals MP. No, sorry. What the hell did I do here? So your probability of A is P. It's times by N 1 minus P plus MP. Okay. So that and that should equal to intersection, which is MP. Okay. So let's expand that. So we're saying Pn 1 minus P plus plus MP squared equals MP. Okay. So Pn 1 minus. Okay, okay. Then Pn minus P squared N plus MP squared equals MP. So Pn minus P squared N, MP minus MP squared. Taking those n's, So common factor, it's p minus p squared. And taking common factor of m here is p minus p squared. These cancel out, so n must equal to m. Okay. So m must equal to n. Okay, that's not too bad. It's such a long question, but yeah, not too bad. So it took very long, I'm not gonna lie, but that's for that, right over here. Okay, next question. 12. If 1 to 4 of f of x is 4, 2 to 4 is this, then what's 1 to this? Okay, so I'm just gonna simplify that. So what we're trying to find is 1 to f of x. Okay, not nice, wait. Dx plus 1 to x dx. Alright, so let's find this first. So if I was gonna, let's say, draw a sketch, a nice sketch, and let's say that 1 to 4 is equal to 4. Let's say a function. So let's say this is 1, and let's say this is 4. And let's say this is 2. So we know that 2 to 4 is negative 2. So it's probably something that's like this. It goes down. And it has that negative area. But we know from 1 to 4, it's positive. So this here should be like very big. Because it, like this adds to this, it brings positive. That's what this is telling us. So 1 to 4, it tells us that. And that's our x value. We don't know what that is. And that's what we're trying to find. From 1 to 2, yeah. So if we add those, so x minus 2 must equal to 4. We get x equals 6. So yeah, so this means what's 6 plus 1 to dx? 1 to x dx. Very nice. So 6 plus x squared over 2, 2 to 1. So 6 plus 2 minus half, 6, 3 on 2, so it'll be cancelling those out. 3 times 3. What have I done? What have I done here? What have I done here? That's not work. Okay. 6 plus. So 2 times 4 is 3 on... Oh, 3 on 2, it's plus, not times. Okay. So that's 12. So 15 on 2. Yeah, so easy answer. Perfect. The graph for the function f passes through the point negative 2 to 7. If h of x is this, and f x is like this, transformations have gone to it to make it h of x, then the graph of the function h must pass through the point what? So this has gone through some transformations through these to get h of x, and h of x, it'll be one of those points here. So what do we know? Well, there is a dilation by a factor of 2 parallel to the x-axis, or from the y-axis. So what does that mean? It means this x value over here gets multiplied, because it's a dilation by a factor of 2. So it gets multiplied by 2. So it will transform to negative 4 to 7. Okay. And there's also a translation of 5 units up, or in the positive y direction. So your y-axis, or your y thing, this over here, gets translated 5 units up. So so 5 units up will be 12. Negative 4 to 12. C. Perfect. Is that right? I'm not too sure. Wait, a graph of the function f passes through the point negative 2 to 7. If h of x has gone through, okay, then the graph of f must pass through the point this. I'll check the answers after for all of them, because I'm not too sure. But yeah, I hope that's right. Dilation by a factor of 2, so it gets multiplied by 2. Because here they trick you. You think it's half, you just shove the function, like this negative 2 into it, blah, blah, blah. But that's wrong. Remember, it's a dilation by a factor of 2. Question 14. The weights of a packet of lollies are normally distributed with a mean of 200 grams. If 97% of these packets of lollies have a weight of more than 190 grams, then the standard deviation of the distribution correct to one decimal place is what? Okay, so what I'm going to do is we're going to draw a nice distribution graph. Normal graph. So this is your mean, which is 200. And we're saying that this is 190. Let's say that's 190 grams. And we're saying if 97% of these packets of lollies have a weight of more than 190, so all of this area right here is 0.97, then the standard deviation of the distribution is what? Okay, so, well, let's try to find this over here. This area over here. It's very easy. It's just 0.03, yes? So if that's 0.03, we can say that the probability of, let's say x in this case, x is less than 190. X is less than 190. It gives us 0.03. We can change that to a normal, like a normal graph. Like, so we can say as a z is less than 190 minus your mean, which is 200 in this case, over your standard deviation is 0.03. And using your calculator, so go on using your calculator, and you can just go on menu. We can go on probability, distributions, inverse normal. And what is the area? Well, we know it's 0.03. Your mean in this case, because we are using the standard normal distribution, our mean for this is 0 and our standard deviation is 1. Okay, perfect. We get this right over here. So we can equate 190 minus 200 over this. It must equal to negative 1.880794 blah, blah, blah. So using your calculator just to calculate your O, your standard deviation. So it's like saying, okay, 190, so it'll be negative 10. Let's say O equals answer. We can say solve answer for O. And we get 5.3. Okay, so 5.3. B looks like the right answer for that one. Question 15. If f is for like 2 to infinity of this and f of 5 is this, the function of g, so the function g is the inverse of the function f, then what's g dash of 7? Okay. Look, I'm just going to do on this by cast, so let me just delete this whole thing and let's just define f of x. Yeah, let's just try to define f of x for this one. So x squared minus 4x plus 2. Okay. And because it's to infinity, okay, and we know that f of 5 is 7, then we know that the function g is the inverse. So to find g, it's just, we can solve for the inverse. So f of y must equal x comma y. So this over here are your two inverses, like they're your inverse functions. Why is there two? Because it's not a one-to-one function. But luckily here, they tell us that f is from 2 to infinity, so it's only positive. So we won't take this negative one, but we'll only take this positive. So this is your inverse. Perfect. So we can say, define that g of x is now, this is your inverse. This one right over here. Perfect. And we want to find g dash of 7. So what's your derivative of this function? We get this. And we want to sub in 7. When x equals 7. And we get 1 over 6. That's your answer. A is your answer. Part of the graph of y equals f of x is shown below. The corresponding part of the graph of y equals f dash of x is best represented. Okay, what do we know? Well, we know that the stationary point will become the x-axis in the f dash of x, the derivative function. So there should be, in the f dash of x graph, it should be a x-intercept at x equals 5. So this one looks good because there's an interceptor over here. That's wrong. Is it wrong? Well, we cannot know. Yeah, there's an x-interceptor over here. What about this one over here? X-intercept at this. Perfect. No, it has x-intercept at x equals 6, so that's wrong. This one over here, it has 2 x-intercepts. No, there's only one turning point, so at 5. This should be it. This one, wrong too, because it's saying at 6. So it can only be A or B. What do we know? Well, if I draw a line here, what can we see? Well, this over here is positive. The slope is positive, meaning that it'll be above the y-axis on the f dash. So, knowing that, looks like A should be your answer. Because we can see if I was drawing a line at x equals 5, it is above. The line is above. Perfect. And yeah, this one should be negative because it's going negative, negative, negative. So it should be pretty much at the bottom for this And yes, it is at the bottom. Perfect. That's done. Question 17. A box contains n marbles that are identical in every way except color, of which k marbles are colored red and remainder of the marbles are colored green. 2 marbles are drawn randomly from the box. The first marble is not replaced, so not replaced, into the box before the second marble is drawn. Find the probability that 2 of the marbles drawn are the same color. Okay, I'm going to draw a tree diagram for this. So we have what colors? So red and green. Red, green. Red, green. And it contains n, so the total's n, and red, so of which k marbles are red, so k marbles. Okay, k marbles are red, so it'll be this, k over n for this one. And to find this, it's just 1 minus k over n, so 1 minus k on n, which is n minus k all over n. N minus k all over n. Perfect. And because it's not replaced, so it'll be k minus 1, n minus 1 for this one, and this will be n minus k minus 1 over n minus 1. Perfect. And what we want to find is, find the probability that the marbles drawn are the same color. So what we want to find is this over here. RR, GG, these two. And if we add them, it's just multiplying this. So what's k over n multiplied by k1, k minus 1, n minus 1, plus n minus k of n multiplied by n minus k minus 1, n minus 1. Okay. So k minus 1, n minus 1, plus n minus k minus 1, or the n minus 1. Because these have the same things, we can just put them all together. Alright, minus k minus 1 all over n. Does one look like this? Plus n minus k, n minus k. D looks right. Perfect. Looks perfect, yeah. Alright. The distribution of a function around the variable x is defined by the probability density function of this, okay. Where a and b are all reals, okay, the graph of the function p is shown, okay. It is known that the average value of p over the interval negative a to b is this, then find the probability of x is greater than 0. So, what I'm going to do here is, okay, to find the average value, we normally, this is the formula, it's 1 over b minus a, so it'll be b plus a, over the interval from negative a to b of the function p of x dx. So the area from negative a to b. And that's easy. I mean, we don't need this. It's just because they're basic, like a triangle and a trapezium. So if I'm going to draw a nice here, triangle, what's the area of this triangle? Well, we know the area of a triangle is half. Your base here is just a. It's negative a, but we just, because we want to make an absolute, so a times 2a. So it will equal a squared. So we can say a squared plus, what's the area of this trapezium? Well, if you know that the area of a trapezium, the formula is half the length of the two, so b plus 2a times this length over here, which is b. I'm just going to write over here, so it'll be half b. Okay. And we add that to this. And that should equal 3 over 4, your average value. What else can we make? We want to make two simultaneous equations to find a and b. Well, we know that the whole area of this should equal to 1. So what can we say? Well, we know that the area of this is a squared, and we know that this is half b, b plus 2a. So adding those together should all equal 1. Now I'm going to put this on my CAS and find the values of a and b. So go on menu, go on algebra, solve systems equations, and we want to find a and b. Okay, let's write them down. So the first one is 1 over b plus a times a squared plus 0.5 times b times b plus 2a equals 3 over 4. This one over here is a squared. I mean, just copy this actually. Yep, so is it the same? Perfect, equals 1. And this, it gives us this over here. But what we know is that a and b are all reals in the positive. So all positive real values. So we can only take these two over here. Perfect. So now we know that these are the values. And we're trying to find the x is greater or equal. So x is greater than 0. It's just trying to find the area of the trapezium. Okay, very easy. The area of the trapezium is just this over here. Put that over here. Given. Now we have our values. Just put them over here. Enter 7 over 9. So that's your answer. D is your answer for that one. Question 19. Given that the tan of alpha equals d, where d is greater than 0 and alpha is between 0 to pi over 2, so in the first quadrant, these some of the solutions of this, where x is between this in terms of alpha is what? Okay, so d is positive, as it says here. So when is tan positive? Well, tan's positive in this quadrant and this quadrant. And our angle, we know it is of tan alpha. So this angle over here are alphas. Yeah. Yeah, so alpha is perfect. And what's our domain? Well, this is x. So remember, we're trying to find 2x. So we're going to multiply everything. So 2x, 5 pi on 2. So 5 pi on 2. So, okay. So what we're trying to find is the solution. So it'll be 2x. The first solution is alpha plus, the second solution is pi plus alpha. Oh, no, not alpha. Pi plus alpha is the second solution. And the last solution, because we're going from pi over 2, which is this point, last point, is 2 pi plus alpha. And so it'll be alpha over 2, pi over alpha over 2, 2 pi plus alpha over 2. Okay. And adding them all together, because we're trying to find the sum, it will be, so the sum is alpha plus alpha, so it'll be 3 alpha plus pi plus, so 3 pi all over 2. And that's your sum, which looks like E is your answer for that one. Yeah. The expression of log x of y, blah, 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 where x and y are all real numbers, greater than 1 is equal to what? Look, I personally cannot be bothered proving this, like, especially in the exam last question. What I'm going to do is, because I know that x, y, and z are greater than 1, let's say that x is 2, y is 2, and z is 2. And what I'm going to do is go on my calculator, Control N all of this, and just say log x, so it says, so log xy equals plus, so log xy plus log yz should equal to, let's try the first one, which is, it says it should equal -1 log yx minus 1 log zy. Okay, and we can say that given that x is equal to 2 and y equals 2 and z equals 2. Done. So the first one's false, so we can say A is wrong. What about the next one? So copy the whole thing again, just change it. So the next one's made these all positive, and this one's x, this is y, z and y. Perfect. So wait, y is supposed to be y and z. Okay, enter. Okay, so log, yep, looks good. So log yz is equal to 1 over log xy log yz. Aha, this one looks good. It's fitting the description. That's good. So the expression of where x and, is that the right answer? Yeah. Okay, I mean, I'm just gonna put a tick on it. It looks right. So if log x, how I did yz, x all greater than 1. Okay, looks good actually. I just want to try the other ones, just for safety. The next ones are just, they put negatives in her, so let's copy this whole thing. And so they put negatives here now. Negative, negative. And it's x, y, y, z. False, okay. What about D? Well, D is, okay, so they've took the negatives all out. And it's log y. X, Z, Y. Enter. True. So we got 2 trues here. Let's try the last one too, just to make sure. Wow. Okay. So it's saying yx, so we can code like this out and say it's saying log yx plus zy. Also, this one seems to be true. Wow. So 3 looks true. 3 of them looks true, but I don't think that's right. So the best way what I'm going to do is, because I know x and y are all real numbers greater than 1, let's change this to 3. Let's change this to, I don't know, 8. Enter. False. Now, okay, E is wrong. That's what it means. E is wrong. So E is also wrong, we can say. Let's double check D. Double check D with this kind of condition. It's better to than getting confused and stuff. It's like this is what I would prefer. So 1 log y of x plus 1 log y zy. Okay, so right everything. Enter. True. Okay, so D is still right, it's saying. What about the thing that B? Double check that, because B also said it was right. So this was x, this is y, and that's it. False. Okay, so only D is the right one here. D is your answer. And that's it, guys. Look, the last question, it's too much to prove. Like, I know that it's very easy to prove, but it's the change in base formula and blah, blah, blah. It's just going to take too long to write and done. I would have done this, just guess and check there. But yeah, I hope you guys enjoyed this video. I hope it helped you a lot. I do tutor online. If you guys want tutoring in VCE methods, specialist, physics, chemistry, please, I have an email right over here on my thing. You can email me down here and we can discuss. Yeah, I also have my email in the link in the description if you guys need tutoring. Yeah, I hope you guys enjoyed this video, and yeah, have a good day, guys. Take care. Bye.